Hey, what's going on, y'all? This is Mr. Lee. I have created a short video presentation on snap circuits, two-way switch circuits. But I also want to use this video to give you a model of how your video presentations are going to be formatted for SmartLab in the future. All right, but let's begin. All right, so this is how the presentation flow is going to be. First, I'm going to talk about the project description, then concepts learned. There's basically two simple concepts, the elements of a circuit and the types of switches. Also have a short video that I made putting in, I assembled my own circuit using snap circuits, and then I was explaining how the flow of energy goes through the circuit. I'm also going to be talking about fun aspects, challenges that I dealt with in the project and how I solved those challenges. All right, so project description. Using snap circuits, my project was to learn how to wire the pieces to model a stairway light so that it can be controlled from two switches, one at the top of the stairs and one at the bottom of the stairs. All right, concepts learned, elements of a circuit, and the types of switches. So I'm going to go into the first one, elements of a circuit. All right, so there are basically four elements to a circuit. Starting from the top right, you have energy source here. Then for this particular setup, this model, on the breadboard, we have a 3 AAA battery energy source. Then we have a control device that's basically your switch, and then you have and back to the control device. It's just this one's a 3-way switch. I'm going to describe those later on. Then I have the path or the wire. Those blue pieces in the snap circuit kits are the wires, or could be thought of as the wires. And then you have a load at the top. Basically, a load is anything that consumes energy in the circuit. So that can be a light, or some kind of sound device, or a meter, but it's just something that consumes energy. All right, so types of switches. All right, so the first type is a press switch. The press switch is a momentary switch which is on when you're pressing the button. There's an example, a live example of it to the left, and then there's the snap circuits piece in the right. And the best example I can think of for a press switch is like the light in your refrigerator. Like when you open the door, the light is off when the door is closed, but it turns on once the refrigerator door is open. All right, so that's a press switch. Next switch we're going to talk about is a slide switch. All right, and the slide switch operates like most lights you find on the wall near any door. Near any door in a room. So if you walk into a room and you hit on the light, basically that's how a slide switch works. Or most of the lights that we use are like kind of like a lever, but for those that do have the slide switch type of light in the houses, or if you've used any device where you had to, in order to turn it on, you had to slide a switch forward or backwards, that's an example of a slide switch. All right, single pole throw switch, and this is the one that I had to work with a lot. This is a special switch that has 3 different connection points. Engineers call it a single pole double throw switch. Okay, so that's another name for it. And at the bottom you have an example of that. And to the right, that's how it looks in snap circuits. Now, we have a variable resistor switch. That's kind of like the lights that you can slide up and down. It's more like a dimmer. It's different from the slide switch that we used earlier, because this one is more like a dimmer. It changes the amount of current in the system, or the current flow in the system. And finally, getting back to the 3-way switches, or the single pole throw switch, All right, and getting back to the single pole throw switch or the three-way switches, in the Snap Circuits kit, it has a singular center position A, which is usually your input terminal, and has two output positions B or C. It doesn't have a specified off position, so you simply throw the switch two different directions. All right, so energy comes in at A and leaves out through B or C. All right, since A is a very important position, as you can see, the switch is on B or C. So if the switch is thrown in the direction of C, then the energy is going to flow through points A and C. If the switch is thrown to the side that B is on, or pole B, then the energy is going to flow through B and A, or through A and B. Okay, so this is my challenge. My challenge was I had to use two switches to create a circuit that allows you to turn a light on and off independently, from two independent locations. Alright, so here I have my circuit. I'm just going to use this pencil to kind of point out different aspects of the circuit. So I have two three-way switches here. I got a couple of snap wires in here. I have my light, and I have of course I have my energy source, or my power source. So essentially what happens is this has to make a full circuit. The flow of electrons have to be complete in the entire circuit for the light to come on and off. Anytime that the circuit is complete, the light comes on. Anytime that it is incomplete or broken, the light turns off. Okay. Now we break or continue the circuit using these throw switches. I'll just use one, kind of turn it on here. Alright, using these throw switches, use that to turn the light on and off. But this is basically how the flow of energy happens in the circuit. Alright, so energy comes in at this point from the negative side. Alright, and it goes through the light. Matter of fact, I'll turn this on so you can see better. Alright, so energy comes in from this side, lights up the light, goes up through here. So now, with the toggle switches, A has to be utilized or connected to a wire in order to complete the circuit. Alright, but all sides, A, B, and C, should have some kind of connections, but in the case that they aren't, let's say one of them don't have a connection, it could either be B or C, but A always has to be connected to the circuits for to allow the flow of energy, or to continue the flow of energy in the circuit. So energy comes up through the wires, comes in at A. So now we notice that the toggle switch is up towards B. Alright, so what's happening is, once energy comes in, the toggle switch kind of directs energy towards the node at B. So now it goes from B through here, over across the wire to C. So C, over here, the switch is up towards C. So that means the energy is coming in through C, and then it's coming out through A and going back to our energy source, and it just completes the cycle. So it goes up through here, comes in through A. This toggle switch is telling it to go towards B, so it's going through here towards C. It comes down. Since this toggle switch is pushed towards C, that means the energy is going to come in through here and come out through A on this side and back to the energy source. So now what happens when I hit one of these switches? So let's push this down. Alright, so now it's down. So this switch is down, but this switch is up. Okay, so that means that the circuit here is broken. Alright, when this was up, oops. So now when this was up, When both of these are up, the circuit is complete. When this is down, this is hard to put. When this is down, that means the circuit is broken. When this one is down, the circuit is complete. The pathway follows as such. Energy comes in, electricity comes in, goes up through here, comes in through A. Alright, so now this toggle switch is pointing down, so now we're redirecting the energy towards B. C on this one. You can't really see it because it's covered up, but it's C. So this goes over here. This bridges the gap to point B on this toggle switch, and then it goes up through here, back out to A, and back to the battery source. So, you know, these are just switching the direct. All these do is just switch the direction or the flow of energy. But in order to make the circuit complete, you just have to make sure that the pathways are unbroken. All right. So these switches have to be in the same, have to have the same orientation in order for the pathway to work. But you can see kind of like how it would work, you know, with a stairwell, you know, because this is a stairway challenge. So if this was the upstairs switch and this was the downstairs switch, let's say if the light was out, all right, and somebody is upstairs, you know, if they want to use the stairway light, they come, boom, hit the light switch on, walk down the stairs, and when they get to the bottom of the stairs, let's say if this is the stairway light for the bottom of the stairs, they throw it back up and the light goes off. If somebody else was upstairs and they wanted to use the light, then they would just push this light up. Alright, once they get downstairs, push it down, and vice versa. But in a nutshell, that's how it works. Okay, so some fun aspects that that I encountered working with the project. One of them was determining the flow of energy in the circuits. It was kind of like a little puzzle, you know, depending on how complicated your circuit got. I mean, for easier circuits, it's pretty simple, but like doing the project that I had done, you know, at first it was a little tricky, you know, determining how the energy would flow through the different switches, but it was tricky but fun. Also learning different switch types and how they're used, not only, you know, with the Snap Circuits kit, but also in the real world. Kind of got into that, you know, that electrician world, you know, real quick. Thought that was good. And also finally just working with Snap Circuits. You know, they're very easy to use. They literally snap into each other. It's a good way to learn, but also have fun. Some of the challenges that I found was finding the Snap Circuits pieces, because some of them weren't in the kits. I guess other students had been using them for their projects and didn't return them back to the kits once it was done. Determining that even though it was fun trying to figure it out, but just determining the energy flow in a more complex circuit system. And then also creating the video tutorial. I had to do a couple takes with that. That was a challenge, but definitely overcame that. Solving the challenges. I remain persistent when searching for materials. I reread my notes and class resources to understand concepts. And then it just came down to grit. You know, when I failed, I tried new things until I was successful. So, you know, those are the things that guarantee your success, not only in this class but also in life.